Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU actuary. Here's a problem for today for exam LTAM. This is problem number 1 from the written answer section from Spring 2020 exam that was actually given in July 2020. A fully discrete joint life 10-year endowment insurance policy with sum insured of $100,000 is issued to two independent lives, both age 70. Premiums are payable annually until the earlier of the first death or on the contract maturity. Sorry. You are given acquisition expenses are $400 plus 50% of the first year premium. Renewal expenses are 2% of each subsequent premium. Mortality follows standard ultimate life table. Interest rate is 5%. The gross premium is $10,658. L0 is the gross loss at issue random variable. A. Calculate the probability that both lives survive to the end of the contract. B. Show that the expected loss at issue for this policy is negative 4,470 to the nearest 10. You should calculate the value to the nearest 1. C. Show that the second moment of life insurance of this endowment policy on 70, joint life status of 70 and 70 over 10 years is 0.44 to the nearest 0.01. You should calculate the value to the nearest 0.001. Part 2, show that the standard deviation of L0 is 30,000 to the nearest 10,000. You should calculate the value to the nearest 10. D, now consider a portfolio of 100 identical independent policies issued to couples both age 70 with independent future lifetimes. Calculate the probability that the aggregate loss at issue is positive using the normal approximation to the aggregate loss distribution. E. In a sub-portfolio of 10 identical independent policies issued to couples with lives both age 70, the age at death of the 10 couples' lives turned out to be the following. And you have information here about age at death of those 10 people, first to die and second to die. Without further calculation, state whether the value of the total profit realized in the sub-portfolio will be greater or less than the expected value of the profit for the sub-portfolio. Justify your answer. And here's the solution. So for part A, we have 10p7070 because of independence is equal to 10p70 times 10p70, and the value that's equal to 10p70 squared, and the value of 10p70 then can be found from the life table. It's L80 over L70 squared, so we look up those numbers L80 and L70, plug them in, and get that probability to be approximately 0.6899722221. B, the expected loss at issue for the policy is 100,000 A 70:70 angle 10 plus 400 minus 10,658 times 0.98 times A double dot 70:70 angle 10 minus 0.48. That's coming from that 2% and half of the premium in the first year. So for the expenses, adjustment for the expenses. And from standard ultimate life table, A double dot 70 colon 70 colon angle 10 is 7.2329, and then using David Ricardo formula, A 70 colon angle 10 is 1 minus D, A double dot 70 colon angle 10, so it's 1 minus 0.05 over 1.05 times 7.2329, which is approximately 0.65557. By the way, the value of D for interest rate of 5% is also in the table. And the expected value of the loss at issue is 100,000 times 0.65557 plus 400 minus 10,658 times 0.98 times 7.2329 minus 0.48. And that's approximately equal to negative 4,473.643236. Part C, Part 1. We calculate standard deviation of L0. We have the second moment for life insurance, this endowment contract 70 colon angle 10. That's equal to the second moment of A 70 colon 70 minus 10p 70 colon 70 times 1.05 to a negative 20th. Remember, that's because we have two lives, so we not exactly. We calculating the second moment. So that's at double the force of interest. And doubling the force of interest means that you'd have to square 1.05 to a negative 10. Times 2a 80 colon angle 80 plus, now if you subtract these two first things that I posted here, what you're going to get is term insurance. And you also need to add the payment at time 10 if this joint life status survives to get the endowment that we have. So that's why we're adding 10p 70 colon 70 times 1.05 to the negative 20th, and that's negative 20, not negative 10, because of the doubling of the force of interest. So that's 2a 70 colon 70 plus 10p 70 colon 70 times 1.05 to a negative 20 times 1 minus 2a 80 colon 80. And all of these numbers are in the table except for the probability, which we calculated. We plug it all in, we get the value of 0.4370226. The random variable L0 is 100,000 times 1.05 to the minus minimum of K 70 colon 70 plus 1 and 10 plus 400 minus present value of premiums after expenses, so 10,658 times 0.98 times A double dot angle minimum of K 70 colon 70 plus 1 and 10 minus 0.48, and that's equal to that 0.48, by the way, it's because the 2% of the 50% is already in the first expression. And we just rewrite it into an expression that has the random part, 1.05 to the minus minimum of K 70 colon 70 plus 1 and 10, and in front of it with 100,000 plus 0.98 times 10,658 times 1.05 over 0.05, and the rest is a constant. And we're going to take the variance of this, and of course the constant doesn't have any variance or covariance. Therefore, the variance is just the square of the constant in front of the random part plus the variance of the random part, which we just find as the second moment minus the square of the first moment of the corresponding life insurance. And now all of these numbers are in the table. We plug them in and we get the answer. And the standard deviation is the square root of that, which is approximately 27,149.6275. In Part D, we are considering 100 independent identical policies. Let us write L0I let us write it for the loss at issue for policy I, for I equal to 1, 2, 3 through 100. The aggregate loss at issue is L equal to the sum from I equal to 1 to 100 of L0I. We also have the expected value of L is 100 times the expected value of L0, So it's 100 times the value we calculated, and it's approximately negative 447,364.3236. And the variance is 100 times the variance of individual random variable, and it's this large number that we have here. Unfortunately, I had a comma in the wrong spot, so I had to correct it. My apologies. And the standard deviation is approximately 10 times the standard deviation we got before. And we are really going to use this number. So that's the number, 271,496.275. Applying the central limit theorem, we can then approximate the probability that the aggregate loss at issue is positive, because this aggregate loss is approximately normal by the central limit theorem. It's a result of adding 100 independent, identically distributed random variables. So probability that the loss is positive is 1 minus the probability that loss is less than or equal to 0, which is 1 minus the probability that and I apologize, I had a L here, but I meant to write Z, because if you subtract the mean and divide by the standard deviation, L, which is approximately normal, becomes Z, or approximately Z. So we're subtracting the mean divided by the standard deviation. Well, of course, then this Z, probability that Z is less than or equal to this, is the value of the cumulative distribution function of the standard normal distribution. And that's 1 minus pi of 1.64777,334. It's approximately 1 minus 0.9505. So this is 0.0495, or approximately 5%. In part E, the total profit realized in the sub-portfolio will be greater than its expected value, because the mortality experience in the sub-portfolio was better than expected, and the death benefits were paid relatively late in the term of the policy, at times 6 and 9. Under the assumed mortality, they would have been paid earlier. Hence, the expected value of the benefits was lower than expected. Well, the present value, not expected present value, my apologies. Hence, the present value of the benefits was lower than expected. Please remember this is copyrighted material. The problem itself was written by the Society of Actuaries, belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.